Okay. Good morning, students. Today we are starting the new chapter. That is chapter number 10. The name of the chapter is Energy, Work and Simple Machines. Energy, Work and Simple Machines. This is the name of the chapter. And the first topic is first section is 10.1. The name of the section is Energy and Work. Energy and work. So basically today we want to know about work. Look, the meaning of work in our daily life and in our physics, the meaning of work are different. Right now when you are studying or I am teaching, actually we are working. If someone asks us what are you doing, then I will say I am working, I am busy. And if someone is asking you what are you doing, you will say the same thing, that I am busy and I am working. But according to physics, the meaning of work is different. And according to physics, we both are not studying, not working. Now, what is the meaning of work in physics? There should be three things. There are three conditions, or the work depends upon actually three factors. First of all, I will tell you the scientific definition of work. And then we will discuss that upon which factor it depends and what is the formula and how we will calculate the work done by an object, by a person, by a machine. See, if a force makes an object to move in the direction of force, then work is done. So see, in this definition, what we are saying, that we have an object that is placed on some surface. There must be someone or a force is needed, so a force must be exerted, and because of this force the object should cover, this is the new position, after exerting the force the object will move and it will cover a distance d. And the direction of the distance is this. See, this is the direction of distance and this is the direction of force. So the direction is important. So work depends upon three factors. And from the definition, see here, work depends upon three factors. Number one, look here, we have to identify if a force makes, so it means force is needed. So we need, number one is force. Factor number two, here you can see the factor number two is if a force makes an object to move. If the object is moving, it means that is covering some distance. So distance should be there. And the last factor three, the third factor is in the direction. So direction is important, like the angle between distance and force. Angle between force and distance. Force and distance. So these are the three factors. Now we will write the formula that how we will calculate work. So it means If work is depending upon these three factors, so its formula will be containing these three components. And see, work is, according to our discussion, work will be equal to F multiplied by D, and then this is cosine theta. This is work, W for work, F for force, this D is distance covered. Take care, this is the angle between force and distance. This is important. Angle between force and distance. And what are the units? We should know. We know the distance, the unit of force is Newton. N, the unit of distance is meters, and angle has just degrees, and this work is joule, or sometimes we say Newton meter or Newton meter. So these two are same. You can write joules, J, this is the full version is joule. We write it with the uppercase letter J. Newton is an uppercase letter N. M is the lowercase letter m. So Newton meter or joule, it's the SI unit. Oh, it's the SI unit of work. One more thing we should know about work. It's a scalar or a vector quantity. Actually, direction doesn't matter for work, so work is a scalar quantity. Work is a scalar quantity. There are some conceptual questions about work. When work is now we can have some examples. How to calculate work, or if someone is pushing the wall, if a student is pushing the wall, is he working? Because he's getting tired. Is he working? So what is its answer? If a student is pushing the wall, see, if someone is pushing against the wall, this is the force. He is exerting force, but there is no distance. But if distance is not there, then work will be zero. Here, the student is not working. The student is not working because no distance is covered. He is exerting force, but distance is not there. That's why no work is done. The student is not working because distance is not covered. Because distance is not covered. Distance is not covered. There is a car, and someone is exerting force of 200 Newton, pushing the car, and the car covered a distance of 7 meters. From here till here is 7 meters. Find the work done. Calculate the work done. This is example 2. Sorry for the disturbance. Okay, so this is example number 2. We have to find work done. Work done. First of all, make the list. Work is missing. How much is the force? That is 200 Newton. How much is distance? That is 7 meters. And what is the angle between force and distance? This is important. So see, this is force. F is in this direction. And this is the direction of distance also. So these two are parallel, so angle will be 0. So theta is 0 degrees. Now write the formula. Work equal FD cosine theta. Force is 200 Newton. Distance is 7. And then there is cosine multiplied by cosine of 0 degrees. Use your calculator to get the answer. See here, 200 multiplied by 7 multiplied by cosine of the angle, that is 0. Close the bracket. Then you will get the answer 1400 joules. So 1400 joules. This is the work done. See, another example is there. If there is a bucket of water filled with water, or someone is holding it. So if you are holding, so the force will be upwards and exerting a force of, you can say 50 Newton. And moving, look, the person can move horizontally on the ground. So I am thinking that he is moving horizontally like this. This is the direction of distance. And how much did he cover? For example, 8 meters. Now we have to find work in this case. We have to find work. So work is missing, force is provided 50 Newton, and distance covered is 8 meters. The angle is important. What is the angle between force and distance? Force is upwards because you are holding, and the distance is this direction. What is the angle? So this angle is 90 degrees. So see, this angle is 90 degrees. Now use the same formula. W equal FD cosine theta. F is 50 Newton. D is 8 cosine of 90 degrees. Then again use the calculator. 50 multiplied by 8 and then cosine 90. Cosine 90. See, the answer is 0. So it's 0, means no work is done. What is the reason? Because in the definition we said the distance must be covered in the direction of force, and here that is exactly perpendicular. So this is the only case when the force is exactly perpendicular to the direction of force, then no work will be done at all. So otherwise, if you are having any other angle other than 90 degrees, you will be getting some work. At least a little amount of work will be there. Okay.